Thank you. Thank you, Joe. Everyone can turn off their pictures if they don't want to appear on the recording. But I really want to thank Professor Tallamy for appearing here. He's the T.A. Baker Professor of Entomology and Wildlife Ecology. He's been at the university for 44 years and published 112 papers. But the reality is he's an entomologist superstar, bringing attention to the need for native plants to sustain nature. He's the author of seminal popular works that have really made a difference in the United States, I would say, Bringing Nature Home, Nature's Best Hope, Living Landscapes Nature Evokes. He's contributed mightily to changing the way people think about landscaping their yards. He researches how what we plant impacts food webs and biodiversity. He's been enormously generous in making himself available for talks like this, and he speaks nationwide about his concerns that the approach to gardening must change. He contends that widespread planting of ornamental plants native to other parts of the world is creating ecosystem-wide dysfunction. And he's been featured and interviewed in the New York Times, NPR, Associated Press, and many other outlets. So thank you so much, Professor. Let me stop what I'm doing here.
Okay. That's a very nice introduction. Thank you.
Thank you so much for coming.
All right. We all set?
Yes. Yes. Looks good.
I want to hear that talk on bison reintroduction.
He's great. That's a good guy to do the talk.
Okay, let's talk about restoring the little things that run the world. And that, of course, is not my phrase. That comes from Edward O. Wilson, E.O. Wilson from Harvard, the late E.O. Wilson, very famous entomologist, ecologist, myrmecologist, conservationist, sociobiologist. He started entire disciplines himself. But one of the things that was consistent throughout his very long career was his love of life on planet Earth and his efforts to save it. He didn't want to save it just because he loved it. He wanted to save it because he knew it was essential to our own survival. So in 1987, he wrote this paper, The Little Things That Run the World. That's when he reminded us, scientists included, that life as we know it depends on insects. And that's because if insects were to disappear, so would most of our flowering plants. And if most of our flowering plants disappeared, it would so drastically change energy flow through our terrestrial ecosystems that the food webs that support our vertebrate animals would collapse. We would lose our amphibians, our reptiles, our birds, our mammals. The biosphere, the living portion of the earth, would rot because we would have lost insect decomposers that rapidly turn over nutrients. All we'd have is bacteria and fungi. Important point here, humans wouldn't survive any of those important changes. So it was a somber message, but it was largely ignored because no one could actually imagine that insects might disappear. This was 1987. We spent a lot more time thinking about how we could kill insects. And besides, if we depend on insects, why do we have National Insect Killing Week? Now, that was 1929, but our culture hasn't changed all that much. Most people see an insect and they do their best to kill it. This was a campaign to boost the sales of all brands of chemicals to rid the community of insects. Not of pests, but all insects. They gotta go. And even if we do succeed in ridding the community of all insects, at least in agriculture and at home, we don't worry about losing our insects because we think that they're still common in our natural areas. And there's two reasons that's no longer true. One is we don't have enough natural areas. We've taken those natural areas and we've turned them into our cities, and they're not, of course, designed to support insects. We've turned them into our suburbs. They're not designed to support anything. Even our rural areas are not designed to support insects. Then how about agriculture? How about grazing? We got 770 million acres of rangeland in the U.S., just 4.5 times the size of Texas, dedicated to cattle, not to insects. And it's typically overgrazed, which means it's very poor at supporting insects. As a matter of fact, food production now claims almost half of terrestrial Earth. And that, of course, is not designed to support insects. Second reason our natural areas are not doing a good job supporting insects is that nearly everywhere they are heavily invaded with plants from other continents. In the Northeast, the Midwest states, it's largely plants from Asia. This is a natural area. This is a park, White Clay Creek State Park, and every bit of green you see in this space here is an invasive species from Asia, because Asian plants leaf out before North America. So I took this picture in March, and you get a very good feel for the invasive load in this natural area. That's a problem because these non-native plants do not support insect populations. As a matter of fact, they destroy them by displacing the native plants that do support them. And we have introduced 3,300 species of plants from other continents, which are now naturalized or invasives in our natural areas. Now we have, in my lab, we have measured what happens to insects, particularly caterpillars, when non-native plants replace natives. This is one study. We've done it in a number of different ways, but this is one study we did fairly recently. We went into hedgerows I went in with an undergrad, and we measured caterpillar communities in invaded hedgerows. So we got a lot of autumn olive here and multiflora rose and oriental bittersweet and so on, and compared them to caterpillar communities in hedgerows that were not invaded. And we got a 68% reduction in the number of species of caterpillars, a 91% reduction in the abundance of those caterpillars, and a 96% reduction in the biomass of those caterpillars, the amount of energy that those caterpillars are providing to that hedgerow. So if you think of caterpillars as bird food, you've just reduced it by 96%. And it's not just invasive species that are causing problems. We typically landscape with non-native plants from other continents, whether they're invasive or not. 83% of our ornamental plants are non-native. So ginkgos, for example, they're not invasive species, but they're also not supporting any caterpillars at all. So they're taking up space that could be supporting viable food webs. Now, when I was young, sites like this were common. I can clearly remember looking up at light poles, and that's what you would see around every light pole in the summertime. This is what your windshield looked like in a lot of places. That just doesn't happen anymore. It doesn't happen anymore. It's anecdotal, but doesn't happen. So the feeling is we are winning our war against insects, even though it is an undeclared war. And we're starting to see headlines that support that feeling, like the insect apocalypse is here. What does it mean for the rest of life on Earth? Of course, E.O. Wilson told us what would happen if we lost our insects. We've had a problem with declining honeybees in recent decades, colony collapse disorder, and that's stimulated people to look at native bees. What are they doing? They're not doing so well either. 50% of our Midwest native bees have disappeared from their historic ranges in the last century. There are 4 species of bumblebees that have declined 96% in the last 20 years. So they're not extinct, but they're functionally extinct. They're no longer common enough to be performing their roles in their ecosystems. There are 3 bumblebee species that probably are extinct, and 25% of our bumblebees are at risk of extinction. They've done a better job in Europe of measuring insect declines. 30% of Europe's orthopterans, grasshoppers and katydids and crickets, are facing extinction. There was a big study out of Germany a few years ago that has been measuring insects since 1989. It's a 79% decline in flying insects since 1989. 46 species of moths and butterflies already have disappeared from Germany. This is the big one. Invertebrate abundance around the world, and we're talking about largely insects here, has declined 45% globally since 1974. This was a 2014 paper by Durzo et al., but a recent estimate is that we've lost 75% of our insects. So none of this is very good news. And of course, as insects decline, so do the birds that require those insects. 432 species of North American birds are now threatened with extinction, according to the State of the Birds report. And it doesn't mean there's only 5 left of each one of those. It means that the trajectory of their population declines is so steep. That is the signal of impending extinction. A study by the Smithsonian said, I guess a couple of years ago, that we have lost 3 billion breeding birds in North America since in the last 50 years. So we have 3 billion fewer breeding birds than we had 50 years ago. We actually went to that paper, and we divided the terrestrial bird species into 2 groups: the species that require insects when they're breeding and the species that don't require insects when they're breeding. So things like doves and finches and crossbills can actually make a little milk out of the seeds that they typically eat, and that's what they rear their young on. So look, the birds that didn't require insects didn't decline at all in the last 50 years, but the birds that require insects declined on average 10 million individuals per species. That doesn't prove cause and effect, but it does suggest that as you take bird food away, you lose the birds. This is an amazing statistic here. England, which gave us the house sparrow and the starling, two highly invasive species all around the world now, it has sterilized its landscape so much that both the house sparrow and the starling are now red listed in England. And it's one of the reasons we're seeing headlines like this. The UN is predicting we're going to lose 1 million species to extinction in the next 20 years. And they made that prediction 3 years ago. So I guess it's the next 17 years now. Most of those species will be insects. And by the way, it's a prediction. It hasn't happened yet. And we have to make sure it doesn't happen because these are the species that run the ecosystems that we all depend on. So does it matter? You bet it matters. The creatures that keep us alive are disappearing. What if I said to you, introduced plants are reducing your bank account by 96%? You would get it right away. You wouldn't need much convincing that that's not good. Well, insects are the currency in our ecological bank account. And it's our ecological bank account that keeps us alive. So it's serious business. It really is. I think our only viable option is to live in harmony, learn how to live in harmony with the natural world that sustains us. So in other words, learn how to live sustainably with the natural world that sustains us. And that world has to include insects. So how are we going to do that? Well, let's talk about where we're going to do it. We've got to do it on private property because most of the country is privately owned. 85.6% east of the Mississippi is privately owned. 78% of the entire country is privately owned. If we don't practice conservation on private property, we're going to fail. And failure is not an option. So this is what a lot of houses look like where I live. I took this picture from a helicopter. There's the guy mowing the lawn. How do we support insect populations in a sterile landscapes like that? Let's first look at the causes of insect decline, and there are many of them. Dave Wagner at the University of Connecticut says insect decline is death by 1,000 cuts. There's so many different causes. But the major ones are the misuse and overuse of pesticides, habitat loss, the plants we choose to landscape in human-dominated spaces, those invasive species. Many of those plants become invasive species. Light pollution is a major cause of insect decline. And then finally, we have climate change. Now, believe it or not, that list is good news to me because all of these can be addressed by an individual at home. Climate change is a little tougher. That's going to require some policy issues, but all of us can stop using pesticides. We can improve the habitat where we live. We can choose the plants that actually support insects. We can change our security lights, and we can remove our invasive species. So let's talk about each one of those, but first decide which insects we want to support at home. There are a lot of insects out there, 3 to 4 million species worldwide. That's an estimate because most of them are still undescribed. Got 164,000 described species in the US, but again, many more undescribed ones. And we're not going to have all of those species in our yard. So which ones should we focus on? Well, I'm going to suggest that we focus on the two most important groups, the insects that maintain plant diversity. Plants are essential. You know, they're the ones capturing energy from the sun, converting it through photosynthesis into simple sugars and carbohydrates, which is the food that supports just about all the animal life on the planet. So we need those plants. So the insects that allow those plants to reproduce are essential. Then we need insects that are going to contribute the most energy to local food webs. In other words, transfer energy from the plants after they make it to other animals. So I'm really talking about pollinators. That's pretty obvious. But then I'm talking about caterpillars. That's not so obvious. So who says these are the two most important groups? Well, I do, and I'm giving this talk. I'm sure there's somebody out there who will disagree with me, but here's my argument. Let's start with pollinators. This, by the way, is a Virginia creeper in bloom. Very small flowers. You don't know that it's in bloom, but it's a wonderful pollinator plant. They absolutely love it. Why do we need pollinators? Well, you hear that we need pollinators because they pollinate a third of our crops. That's what the media tells you. But May Berenbaum at the University of Illinois has looked at that figure. She can't find where it came from at all, so she calculated herself how many agricultural plants depend on pollinators, and it's really about 1/12 of our agriculture plants depend on pollinators. So the real reason we need pollinators is because they're pollinating 80% of all plants and 90% of all flowering plants. including some ag plants. But we need those other plants as well. I hear people say, "I don't live next to a farm, so I don't need to support pollinators." I say forget the agriculture argument. We need to support pollinators everywhere because we need plants everywhere. This is not good land stewardship. This is essential land stewardship. We cannot live without pollinators. All right, what is a pollinator? Well, a pollinator is an insect that transfers pollen from the male part of the flower to the female part of the flower. And most of the insects that visit flowers don't do that. They're flower visitors, but they're not actually pollinators. So they're there to take advantage of the nectar that's in the flower or eat the pollen, but they're not actually pollinating the plant. The real pollinators, the ones that are doing the most pollination, would include one species of honeybee that's introduced from Europe, of course. It's a very good pollinator. We've got 3,600 to 4,000 species of native bees that did just about all the pollination on the continent before we brought in the honeybee. So these guys are essential as well. Then we have 14,000 species of moths and butterflies, many of which are really important pollinators, many of which aren't, but they're underappreciated because they do most of their pollination at night when nobody's looking. But that's a lot of species. Even if they're not that efficient, they can transfer a lot of pollen. Okay, the next question is, if we're going to focus on bees, particularly native bees, what is a bee? I suggest to people that they start to landscape in a way that supports native bee populations. And I often hear, well, no, I'm not going to do that because I don't want to get stung. And I say, well, you're not going to get stung because the native bees are not aggressive. Most of them are solitary. They're not defending hives. You can pet them while they're foraging and it'll be fine. And they say, well, no, you're wrong. I got stung last week. And what they really got stung by was not a bee at all. It was a wasp. It was probably a yellow jacket or a bald-faced hornet. They are social wasps. They're protecting their hives. They are very aggressive, and I'm not suggesting you have them in your yard. The real ones we want to have in our yards are the native bees, which have little branched hairs, in case you're wondering how you know what a bee is. But again, they're doing most of the pollination out there. So how do we support our native bees? Well, you have to give them what they need. They need a place to live, and they need something to eat. So where do native bees live? Where do they nest? They're ground nesters, they're woody stem nesters, and they're excuse me, an old cold. Pithy stem nesters. And it turns out that most of our bees are ground nesters. 70% of our native bees nest in the ground. They sink a single tunnel straight down like a mine shaft, and then they have side shafts going off that central tunnel. And they pack them full of pollen and then lay an egg on it, and the larval bee develops on that egg. Then they close up the hole, and the next season, those bees will emerge as adults. So you can have ground nesting bees any place you have ground. And I think most of us do have ground on our properties. They have a slight preference for a little bit of a south-facing slope. And when the soil is easily excavated, that helps as well. But there are species of bees that will tunnel right into the hardest clay. Now, these ground nesting bees, they can be numerous in certain places. And they'll fly around. What they're doing is orienting around their hole so they can find it again. A lot of people think they're coming after them. You know, they think they're going to sting them, but these guys are very shy. If a shadow falls on them, this is a little Calides bee, it dives back into its tunnel and won't come out until you leave. Okay, pithy stem nesters and woody stem nesters. This is a nice picture from by Heather Holm that shows what they do. They make cells inside. First, they hollow out that pithy stem. Then they create a cell, block it off with a substance here, and then they pack it full of pollen. Then they lay an egg on it. The egg hatches and the larva starts to eat the pollen. This is what a larval bee looks like. Not much. So this one's a little bit younger. So this guy's smaller. This one's younger yet and hasn't eaten that much pollen. And they go right down the line. And when they mature, they pupate in these cells. Then they tunnel out laterally through the pithy stem. And that's the same with woody stems. So what do I mean by pithy stems? I'm talking about the stems of our goldenrods, our echinacea, our evening primrose, ironweed, a lot of the things that we have in our prairies or meadows, which is why we suggest not cutting all them down in the fall or even in the spring. It turns out that the bees that are going to nest in these pithy stems are going to do it next summer. So these guys have to overwinter, and then they will nest in the standing stalks the next winter. So if we cut them all down in March or something, then there's nothing for those bees to nest in. So again, Heather Holmes suggests we cut them down maybe 15 inches off the ground, so you can get rid of the old stems that had the seeds on it. And this would be in the spring. You don't cut them down in the fall because your sparrows and many of the overwintering birds want to eat the seeds of these plants. But you can cut them down 12, 15 inches off the ground. The new growth will grow up past them, so you won't be able to see it, and the bees will nest in those old stems. Same thing with woody stems, particularly wood that is easy to excavate, like elderberry. Elderberry branches die regularly. They don't live that long. But what do? We typically prune them out. Everybody knows that's a good habit to have, but not for the bees. If you can leave those, they will tunnel them out, and then these guys have already emerged, produced 5 bees. But most people in a residential neighborhood do not have enough coarse woody debris where these bees are nesting. So we've invented bee hotels. Everybody loves their bee hotels. These are simply holes of different widths that are drilled into a block of wood, and the bees do use them. They tunnel, or they don't have to tunnel. The tunnel is already made, but they pack them full of pollen and seal them off and reproduce in these holes. People love bee hotels so much that they go crazy making them. So it's a lot of fun. The bees do use them, but there is a downside, research has shown, and that is when we make large bee hotels, you're concentrating all the bees in one place. So if a predator or disease finds that place, you lose a lot of your bees. So it's much better to have small bee hotels, maybe not as much fun, but you scatter them throughout your yard so that you're not putting all your bees in one basket. If a predator finds them, it won't find all of them. This is a really handy way. You get an old stump that beetles have emerged from, and there's all different size holes in them, and the bees will use that. So you don't have to drill anything. Okay, what do bees need to reproduce? They need pollen, and they need nectar, and they need it all season long. Here are data from Jared Fowler, worked with Sam Droege in New England, and he found this is the distribution of native bees emerging from March all the way to November in New England. So it shows you need flowering plants from March to November in New England. And as you move farther south, you need flowering plants even longer than that. Because that's forage. That's what the bees need. The next question is, what species of plants do we need for our native bees? And that's a very good question. And Sam Droege, he's Mr. Native Bee, he says, meet the needs of our specialist bees. A third of that 4,000 species of native bees can only reproduce on the pollen of particular plants. If you don't have those plants, you've lost a third of our native bees. So if you plant a garden that's rich in the plants that specialist bees need, the generalist bees like bumblebees and honeybees can use those plants as well. But if you only plant for the generalist bees, then you've lost your specialist bees. Why are bees specializing? Well, there's a very close relationship between some bees and flowers, because the flowers want the bees, they want specialist bees to pollinate them because they want those bees to take their pollen to the same species. They don't want to waste the pollen of let's say, a willow plant on an echinacea. That's not going to work out. So, flowers, of course, differ in lots of ways. They flower at different times. They look different. They smell different. They have different morphology, different size petals, and the depth of the corolla, and so on. The pollen morphology is species specific. These little nooks and crannies evolved to grab onto the hairs on particular species of bees, so the pollen, they're transported the most easily. And pollen also differs a lot in its nutritional value. Those are all opportunities for bees to specialize on particular pollens. So you won't have Andrena facilii unless you have Phacelia. That is the only plant that bee can reproduce on. You won't have Andrena asteroides unless you have native asters. You won't have Andrena eriginei unless you have spring beauties. You won't have Calides albescens unless you have false indigo. There are a lot of specialist bees out there. These plants are the best plants in particularly the upper Midwest for specialist bees. Our perennial sunflowers, Symphyotrichum, the native asters, very good. Goldenrod's very good. Evening primrose. If you have just these three genera of plants in your yard, you can have up to 44 species of bees that will breed in your yard. If you don't have them, that's 44 species of bees that can't breed there. And then you go right down the list. Most plants do have specialist bees associated with them. So a planting like this, now this would be great for fall bees, and of course the migrating monarchs is wonderful for not just the generalist bees, but the specialist bees as well. How do you know what the best special plants are for specialist bees where you live? You go to National Wildlife Federation Keystone Plants by Ecoregion, and it will give you a list of the best plants where you live. All right, that's all we're going to say about bees. Let's talk about those caterpillars, the meat and potatoes, the bread and butter of terrestrial food webs. That's what Dan Jansen says, very famous ecologist. They are transferring more energy from plants to other animals than any other type of plant eater. So if we design landscapes that don't have a lot of caterpillars in them, we're going to have failed food webs and eventually failed ecosystems. So caterpillars turn out to be really important. So how do we increase the number of caterpillars in our yards? Well, you put the plants that support those caterpillars in our yards, which seems pretty easy, but there is a catch, and that is that most plants don't support a lot of caterpillars. So we have to be fussy about it. We have to be fussy about the plants we choose because the caterpillars themselves are fussy about it. And it's the plants that have made them fussy. Plants don't want to be eaten. They want to capture the energy from the sun and use it for their own growth and reproduction. So they've loaded their tissues with nasty tasting chemicals, secondary metabolic compounds that make those tissues either bitter or downright toxic. And next summer, if you can remember to do this, go out and eat a plant and see if you like it. You're not going to like it. It's a really effective defense. It keeps most of the insects of the world from eating most of the plants of the world, which is why it's green out there in the summertime. It's not because there's no insects out there that want to eat those plants. It's because most of the insects that are out there cannot eat most of the plants. They are too well protected. But insects do eat plants. So how do they do that? How do they get around those chemical defenses? Well, most of the insects that eat plants are what we call host plant specialists. They can only eat plants for which they have adaptations that allow them to circumvent all of those defenses. They have specialized enzymes that store and excrete and detoxify those compounds, behavioral adaptations and life history adaptations that minimize the insect's exposure to those compounds. But it takes a long period of interacting with those plants for all those adaptations to fall into place. It does not happen overnight, and that's why when we bring in plants from other continents, our native insects are unable to use them. That's a generalization, but they can use them far less effectively than they can use the native plants that they have co-evolved with. There are three kinds of plants out there. Plants that contribute a lot of energy to local food webs, plants that do not contribute energy to local food webs, and plants that actively remove energy from local food webs. The very best contributor in 84% of the counties in which they occur is one of the oaks. They're contributing more energy to local food webs than any other plant genus by far. Good example of a non-contributor would be a ginkgo. Ginkgo biloba from Asia. It's a good ornamental plant, has good fall color, but nothing eats a ginkgo, which means it's not adding any energy. It's captured energy from the sun, but it's not passing it on up the food web. And a good example of a detractor would be Callery pear, Bradford pear, privet, burning bush, any of these invasive ornamentals that we brought in, because not only do they not pass on their energy, but they escape and they biologically pollute the ecosystems around us. When they become invasive like this, they have pushed out the contributing native plants, and that means a net loss of energy from that local food web. So all I'm trying to say here is that plant choice matters. If we're going to restore ecosystems, if we're going to do the restoration a lot of people are interested in these days, we have to do it with the right plants or it won't work. You won't have functional food webs in those ecosystems. So for example, if I want to have the beautiful Pandora Sphinx at my house, and by the way, I do want the beautiful Pandora Sphinx at my house, I need to plant Virginia creeper. That's their favorite host plant. If I want the tulip tree silk moth, I need tulip tree. If I want luna moths around this part of the world, they're going to do best on sweet gum. Zebra swallowtail, wherever you go, it requires pawpaw. It's a real extreme specialist. And when I say requires, I'm talking about the caterpillar. They're specializing on the leaves of these plants. Grape, our native grapes support a lot of insects, like the eight-spotted forester moth. Viburnums support the green marvel. Goldenrod, 110 species of caterpillars eat goldenrod, like the beautiful brown-hooded owlet. Even poison ivy supports moths, like the beautiful Utilia. And everybody wants to get rid of poison ivy because they're afraid they're going to get it. But you know when you get poison ivy? When you try to get rid of it. Just leave it alone, learn what it looks like, and don't touch it. Persimmon supports the sculpture moth. Black gum supports the Hebrew. Our ashes, our beleaguered ashes. There's a lot of sphinx moths on ashes, like the fawn sphinx. So we hate to lose them. Maples are important plants. The beautiful rosy maple moth. Of course, the royal walnut moth on walnut and hickory. This is already extirpated from New England. Very sad. Elm, wonderful plant. It supports the double-toothed prominent and many others. Witch hazel dagger moth is on witch hazel, believe it or not. The imperial moth on pine. Spotted thyrus on clematis. Native clematis. It won't touch the non-native clematis. The shy cosmet develops in the seed heads of cattails. Two-toned ancillus on ironwood, the lost owlet on buttonbush, the herald on native willows, snowberry clearwing on coral honeysuckle. That's the native honeysuckle. Evening primrose moth is on evening primrose. You know, if you plant it, the moth will come and spend the day with its head stuffed in the flowers. Sometimes it's crowded in there, but it's a wonderful way to see that moth. Showy emerald on sumac, and I'm not talking about poison sumac. I've never even seen poison sumac. I'm talking about smooth sumac or staghorn sumac. Wonderful soil stabilizers and produce this beautiful moth. Then we have some real powerhouses, things like our native prunus, our native cherries, produce the white furcula, the crocus geometer, the Io moth, the beautiful cecropia moth, the colorful zale, the tufted bird dropping moth. Who wouldn't want the tufted bird dropping moth? The paddle caterpillar. Send your kids outside, tell them to find the caterpillar on black cherry, and ask them to figure out what those paddles are for. They are not decorations. And don't tell them. And I'm not going to tell you either. I want you to figure it out. It's the same reason that the filament geometer has these expandable filaments on its back. The small-eyed sphinx, all these guys are on black cherry. Harris's three-spot, it holds an umbrella of its shed head capsule skins there. And if you get close to it, it'll whack you with it. The beautiful snowy shouldered Aclaris. And then we have the most powerful plant of all, the oaks that are supporting hag moths and the red wash prominent, the white dotted prominent, the spiny oak moth, the skiff moth, white blotch heterocampa, the oak skeletonizer, the solitary oak leaf miner, orange patch smoky wing, half oval ancillus, the crown slug. These guys are called slug caterpillars because their head is tucked up underneath, not because they're really slugs. Pink striped oakworm. This is my favorite, the spun glass slug caterpillar. And hundreds more use oaks, which is why I call oaks keystone plants. Remember what a keystone is? It's the stone in the middle of the Roman arch. And if you take that stone out of the arch collapses. Well, if you take keystone plants out of your local food web, the food web collapses because they are making most of the food. Just 14% of our native plants are making 90% of the caterpillar food that drives those food webs. So think of the keystone plants in the ecological house that you're building as the 2x4s that hold that house up. They are the support system. You cannot build a house out of wallpaper. That's what we've been trying to do for the last 100 years with those ornamental plants from other continents. Again, oaks, number one keystone plant in most parts of the country. In the mid-Atlantic states, they support 557 species of caterpillars, over 950 species nationwide. No other plant genus comes close to that. How do you know what the best plants are where you live? You go to Native Plant Finder in the National Wildlife Federation website, put in your zip code, and the ranked list of the most important woody and herbaceous plants in your county will pop up. These are abbreviated lists because I ran out of room. So the old excuse of not knowing what to plant is just an excuse now. We do know what to plant. Native Plant Finder. So you might wonder where I took all those pictures. I took them in my yard, and this is what my yard looked like. I should say our yard. My wife lives here too. When we moved in the year 2000, it was a farm that was broken up into 10-acre lots. Very old farm, been farmed almost 300 years. And the last thing I did was mow it for hay. Um, Now, when you mow for hay in southeast Pennsylvania, you're really mowing the rootstocks of all the invasive plants that have invaded. So things like autumn olive and multiflora rose, Noriel and bittersweet, Japanese honeysuckle. So when you stop mowing, all that comes back. So you have to remove that stuff. But when you do, and you put in the native plants again, you can rejuvenate your local ecosystem. How do I know that? Well, because that's what we did and it has happened. Has life returned to our property? You can measure that in a lot of different ways. We're measuring it by the number of breeding birds that are making a living on our property, not flyby, but breeding birds, and the number of those all important moths. I'm taking a picture of every moth species that I find on our property. I've been doing it for 8 years, but I'm still at it. And I'm up to 1,337 species of moths that I have photographed right here. Why? Because we put the plants back. We planted all of these plants, witch hazels and oaks and persimmons and American elm, all these guys. But we tolerated a number of native plants that a lot of people get rid of. A lot of people think black cherry is a weed. Those native grapes, they get rid of them all the time. Tulip trees, kind of a weedy tree. Virginia creeper, for some reason, people don't like Virginia creeper. There's poison ivy, greenbrier, dodder. Every time you add a new plant lineage to your yard, you are adding species of moths. And when you add species of moths, you're adding the food that drives those bird food webs. So we have wood thrush now, believe it or not, on that bare property. We've got breeding wood thrush because we've got Virginia creeper making lettered sphinx moths. We've got indigo bunnies because we've got alders making ruby quakers. We've got chipping sparrows because we've got black walnuts making gray edge boma locas. We've got field sparrows because we've got oaks making red line panapodas. We've got tufted titmice because we've got black cherries making dowdy pinions. Phoebes because we got native grasses making skippers, robins. Everybody knows robins eat worms when they're not eating all those native plants that are produced by the weeds on our property, which are really good native plants. We got Carolina chickadee because we've got tulip trees making tulip tree beauties. We've got white-eyed vireas because we've got spicebush making spicebush swallowtail. House wrens because we got hickories making copper underwings, bluebirds because we got sycamores making drab prominence. We have recorded 62 species of birds that have bred on our 10 acres. Again, not flew by, but bred because we've got the caterpillars that they need to breed. Why am I telling you this? Well, this is another headline we see all the time. World Wildlife Fund says that Earth has lost 2/3 of its wildlife since 1970. It's a terrible statistic. But I'm thinking, gee, not at our house. I'm convinced we have increased biodiversity by more than 2/3. It didn't take that long, and it wasn't that hard. We just put the plants back. What would happen if everybody put the plants back? We really could turn a lot of these headlines around. So by choosing the right plants and using more of them, we could restore insects pretty much everywhere. So I'm going to leave you with 11 things you can do to increase the ecosystem function in your yard by restoring insect populations. And the first one is to reduce the area you have in lawn. Got a lot of lawn out there. About 44 million acres is the latest estimate. That's an area bigger than all of New England dedicated to an ecological deadscape. There's four things every property has to do. Every property has to manage a watershed. Every property has to support pollinators. Every property has to support a viable food web. And every property has to sequester carbon. Lawn does none of those things, which is why I pick on it all the time. So why do we do that? Well, it's a status symbol, and we like neat, and we have to display our Halloween decorations. But we can reduce the area of lawn. I drive by this church in Mississippi when I go down there, and it always strikes me that people are inside worshiping God's creations, and on the outside they're killing them all. They're not thinking. They're not thinking. Plant for specialist bees. We talked about that. Remove invasive species from our property. We didn't talk a lot about that, but it depends on where you are in the country. But these are major invasive species in a lot of places. English ivy, Callery pear, Bradford pear, still sold in our nurseries in different states. Porcelain berry, that's a kudzu of the north. If you see that for sale, please ask them to remove it. Burning bush, terrible invasive, particularly in the north. Privet, terrible invasive, particularly in the south. There's 1 million acres of privet in Alabama alone. Chinese elm bad, buckthorn bad in the north, Elmer honeysuckle all over Tennessee, and well, it's all over everything there, and many others. So make sure if you have these on your property, get rid of them. Okay, use keystone plants. We talked about how important that is. Those are the plants that are going to support the local food web. Landscape for caterpillars. What do I mean by that? I'm talking about landscaping under our trees. We've got the right tree here to make caterpillars, but if you don't landscape under the tree properly, those caterpillars will not be able to reach adulthood. This is just an example. I live in Chester County, Pennsylvania, where oaks support 511 species of caterpillars. A few of them, like the polyphemus moth, complete their development on the tree. The caterpillar eats the leaves, then it spins a cocoon and hangs from one of the branches, then it emerges as an adult, then it does it all over again. Everything happens on the tree. But that's unusual. Most species, 94% of them, drop from the tree after they finish growing as caterpillars, and they wiggle their way underneath the ground and pupate underground, or they spin a cocoon in the leaf litter that's under the tree. And that's the problem. There is no leaf litter under the tree. We don't tolerate it. It's messy. And we mow and compact the areas under our trees so that they're rock hard. So particularly in the summertime, when caterpillars drop down, they can't get underground to safety. These are oak trees, very, very popular trees with those moths. The adults will lay eggs here. The caterpillars develop, drop down, and die. So it becomes an ecological trap. And of course, the cement landscape is not the answer either. It's what most people do. You got a tree in a yard. I've got a grad student, Emma Jonas, now, who's just finishing up her master's. She has measured how well caterpillars do in a situation like this. But of course, they do much better in a layered landscape like this. Heather Holm calls this soft landing. And what the important factor here is that it's a no walk zone, no mow zone. So the soil is not compacted. And that makes a major difference for those caterpillars. They can get underground easily, and there's also leaf litter in there that they can use to spin up their cocoons. Much higher survivorship. This is where you can do your spring ephemeral gardening. You put big beds around your trees. The bigger, the better. And that's how you reduce lawn. If you had a big bed around every tree, you would have far less lawn. Your trees would be happy, and so would those caterpillars. You can use the very common ground covers that are out there, like a wild ginger, mayapple, foam flower, ferns. We got a lot of options. The Virginia creeper I talked about. That's green mulch. If you can see the ground, you don't have enough plants out there. Caterpillars will love it, and so will your trees. Okay, reduce light pollution. Light pollution turns out to be a major cause of insect decline. Excuse me. Lights kill moths, and they do it in all these different ways. The moths will bang into the lights and kill themselves that way. They get exhausted by flying around. They get incinerated by hitting a hot light, dehydration. Predators come pick them off, on and on and on. But this is good news to me, because this is a serious environmental problem, but it has a very easy solution. You just turn off your light. But I know people say, well, I can't turn off my light because the bad man will come. Okay, put a motion sensor on that security light so it only turns on when the bad man does come. The rest of the time, it's off. Even easier is to take the white bulb out of that security light and put in a yellow bulb, because yellow wavelengths do not attract nocturnal insects. You can go to the hardware store and buy what's called a bug light. It's simply yellow lights, and it will not attract those insects. So if we were to switch out our white bulbs for yellow bulbs overnight, we would save millions of insects. And if we used LEDs, we'd save millions of dollars as well. Oppose mosquito spraying. This is the booming business around the country, and the mosquito sprayers say it's okay because what we're spraying, what we're fogging is a natural organic product, and it only kills mosquitoes. Well, it's kind of natural and kind of organic, and it's based on pyrethroids that are made by chrysanthemums to kill insects. But cyanide is natural and organic. Ricin is natural and organic. So being natural and organic doesn't make it warm and fuzzy. They also say it only kills mosquitoes. Not even close to true. It kills all the insects that it comes in contact with, including our friend, the monarch butterfly, which has now lost more than 96% of its population. All the pollinators that we're trying to make, these guys come and kill all the insects that we just talked about. The interesting thing is they don't control mosquitoes. You don't control mosquitoes in the adult stage. It's too hard. You got to kill 90% of them to get good control. These guys kill between 10 and 50%. So they have to keep coming back and back and back, and they never actually control the mosquitoes. If you really want to control mosquitoes, you do it in the larval stage with mosquito dunks. Get a bucket. Oh, come back here. And fill it full of water. Put in a handful of straw or hay, maybe some dead leaves, put it out in the sun for a few days, and it'll build up the populations of diatoms and algae. And that is what mosquito larvae eat. So this becomes an irresistible brew to any female mosquito in your yard. She will lay her eggs in your bucket. Then you go to the hardware store and you buy a sheet of mosquito dunks. This is Bacillus thuringiensis, natural bacterium that only kills aquatic diptera. And the only aquatic diptera in your bucket is a mosquito larva. This, by the way, $12 for a season's worth of control. It's cheap. It's targeted. It's not killing anything that you don't want to kill. And if everybody did it, it would be effective. This, by the way, is effective too. Just plug in a fan, put it on your picnic table, and you can have your little cocktail in the afternoon. Sit in the directed breeze, and the mosquitoes will not fly into it. Since we're talking about insecticide use, let's minimize all insecticide use. It's not necessary. When you go to the hardware store and you look at the rows and rows of home insecticides that are for sale, you can tell a lot of people are buying insecticides because they see an insect. The only insects we really need to control at home are termites, and they're professionals that do that. They use baits. You don't have to worry about it at all. And that includes bug zappers. We did a study way back in 1996 looking at the percentage of kill in a typical bug zapper. We put up trays under the bug zappers and caught the insects that were killed. And it's 99.98% of the insects killed are not biting flies. They're not mosquitoes. They're not ceratopagonids. They're not anything that would bother you. So all those zaps turn out to be non-targets that are actually driving the food web. We're killing them for nothing. Finally, share a native plant. You know, the supply of native plants in the nursery industry is not meeting the needs of the demand at this point. Now it'll increase, but in the meantime, you can gather things like acorns, put them in a pot, and grow your little oak tree, and then give it to somebody. This is how we spread this. A lot of people say, well, I can't do anything you tell me because my homeowners association does not allow it. Well, that does exist, but I suggest you join your homeowners association, educate them from within. Your homeowners association is people, and most of them are actually reasonable people. They just don't know. They think native landscaping is the lack of landscaping, and they think it will reduce property values. So you have to tell them otherwise. All right, we're going to end the way we started with E.O. Wilson. In 2016, he wrote this book, Half Earth, Our Planet's Fight for Life. And he had one simple message. He said, if we're going to save life anywhere on planet Earth, we're going to have to save nature. We're going to have to save functioning ecosystems on at least half of the planet, or it will disappear everywhere, and that includes humans. Very bold statement, but he spent most of the book talking about the science that supports that bold statement. And then he ended the book. He didn't spend a lot of time telling us how we were going to save nature on half of planet Earth. Of course, a lot of people are wondering, how can we possibly do this? To conservation biologists, a great idea. We'll just put half the Earth aside, and all those things that are trouble can be in that half. We'll be in the other half, and it'll be great. But to realize E.O. Wilson's dream, we really need a new approach to conservation. No more humans and nature being segregated. We've got to give up the ideas that humans and nature can live together. We can coexist in the same place at the same time. As a matter of fact, that is the only productive way forward. That does not mean that you have to save insects for a living, but you can save them where you live, and if you do, it empowers you. There are more and more people that recognize, planet Earth has a lot of serious issues, but they feel powerless. What can one person do? Well, One person can shrink the lawn, one person can fire Mosquito Joe, one person can change their lights, one person can remove their invasive plants, one person can plant a pollinator garden, one person can plant keystone plants. There's a whole bunch one person can do to revitalize the ecosystem on their property and then enhance their greater local ecosystem instead of continuing to degrade it. And it also shrinks the problem down to something that's manageable for each one of us. Don't think about the entire planet's problems. You get depressed. Just worry about the piece of the planet that you can influence. If you own property, it's obvious. That's where you start. If you don't own property, help somebody who does. Help a park, help a preserve, help a land conservancy. They're all underfunded, all understaffed. They'll love you as a volunteer. So insect decline is a serious global problem, but it has a grassroots solution. There are millions of us out there who can become conservation biologists at home and help solve this problem. So we create it, but we can solve it. Thanks very much.
Thank you so much. Thanks so much for doing this and for coming to talk to us. I know it sounds like you have a cold, but I'm gonna
I'm sorry about that.
no, it's totally fine, but maybe I can ask a couple of questions if that's okay. Yeah, I hope you can drink a little bit of
Yeah.
tea or something. One person asked about the hedgerow photo at the very beginning. Was that kudzu? Do you know at the very beginning? What is that?
In the hedgerows, we went in and monitored the.
Well, you said that was a mix of, there was a photo early on before that.
Okay. No,
Yeah,
that was White Clay Creek State Park in Newark, Delaware. We have a little bit of kudzu up here, but not much. It was mostly multiflora rose and Oriental bittersweet and Japanese
oh, okay.
honeysuckle and bush honeysuckle and autumn olive.
A diverse,
Those
yeah.
are the ones here. Yeah.
Right. Okay. And another person asked about the number of lepidopterans in the United States, the number of species
14,000 species.
in the US. Okay.
Well, in North America,
Okay. Oh,
Now,
and yes, right.
12,000 of those are described, but there's an estimated 2,000 that are not described yet.
Oh, wow. Okay. Another person asked, are flies pollinators?
Well, some of them are, and you know it when they are because the flower is typically brown and it smells like carrion. So pawpaws is a great example. They're fly pollinated. They will smell. It's not a bad smell, but it's not a good smell either. And they attract flies, and that's how they get their pollen spread. But that's more unusual. Ants do a little bit of pollinating. A few beetles do pollinating, but the major pollinators are those bees.
Right. I sort of had a question about pesticides. I mean, we can, I agree with what you're saying in terms of, personal responsibility for reducing our pesticides, but there's so much huge landscape that, agricultural areas and it's hard for me to see. And Illinois is a big agricultural state where we have talked about pesticide, reduction, and it's not going to happen basically. I mean, is there a good way forward with that? Yeah, tell me how to do that.
Don't give up on that. One of the major problems we have are neonicotinoid seed coating. Studies have shown that you can compare yield when you use the seed coating and when you don't. There's no difference. We're using all of that neonicotinoids, 90% of which washes off before it's not taken up by the plant. Only 10% is taken up by the plant, and the other is either washes off when it rains or blows away on dust. And it's not increasing yield. This is totally unnecessary. We use it because the companies make it and everybody buys it and it's cheap. But that's not a good reason to be poisoning the world. Neonicotinoids are, what's the figure? 7,000 times more toxic to insects than DDT was. It's serious stuff. So it's not that you're going to make farmers starve to death here. It's a ridiculous practice. It's already banned in Europe, and they're still alive. So so don't give up. Don't give up on that.
Okay, good. Should I keep bee hotels outside or bring them inside in the winter?
No, keep them out, but out of the rain too. They need to go through their winter cold. If you bring them inside, the bees think it's summertime and they'll emerge at the wrong time. So definitely keep them outside, but they should have some kind of roof over them so they don't get rain soaked.
Right, right. Another person, there's a little conversation here about planting parsley and dill to attract swallowtails. I know they're not native plants. People suggested some native plants, but she said, I have a lot of golden Alexander, but the caterpillars seem to really like the herbs.
Yeah. Well, first of all, they're all closely related, which is why the black swallowtail can use them. They're in the carrot family. And the reason they like those herbs is because we have bred out the plant defenses. Golden Alexander is loaded with them. So that's what the swallowtail used to use, but now all of a sudden they have something they don't have to break down. I say, well, we'll do that. It tastes better. So we made it easy for them. And that's true for most ag crops. We have bred out the plant defenses, which is why they have so many insect pests.
Okay. Technical question, what camera system do you use on insect macro photography?
I have a Nikon, but Canon is just as good. I started out with Minolta. It's really about the lens. I have a micro Nikkor lens, what do you call it? Macro lens. But that's also really about the flash. Macro photography requires flash because you have to use a high f-stop. Otherwise, you lose depth of field. And when you use a high f-stop, you lose light. So you need to have artificial light. But when you put all those things together, insect photography is actually a whole lot easier than bird photography because those insects stay still. The real trick is finding them. If you find them, you can get a good picture.
Right. Okay. How do native grasses used to replace turf lawn help pollinators in addition, like pen sedge, in addition to storing carbon roots and not needing watering, mowing, etc.? So I guess that's about skippers and things, maybe.
Well, maybe, but we'll point out that grasses are wind pollinated. So it's not that they're producing pollinators that are going to help grasses. But yes, most skippers are specialists on grasses. And skippers, of course, go to flowers and they do move some pollen around. They're not the only thing that eat grasses. Grasses support a lot of different things, but grasses are wind pollinated.
Okay. Okay. I thought it would be helpful to just mention before when we were figuring out our sharing technology here, you mentioned ashes and maybe keeping some of the little ashes to see if there's some resistance growing. And where there was a little conversation about chestnuts and elms. I wondered if you could say something about some of these bugs that are taking out the trees and
Right. We've brought in, serious insect problems for our native plants, the spongy moth and the emerald ash borer, the hemlock woolly adelgid. Very few of the trees are actually resistant to these. And of course, we don't know what they are until after the insect comes and we see what doesn't die. If you cut your ashes down preventively, you have lost the opportunity of finding out if there's any resistance there. So there's that. We also have biological control programs that are actually starting to work. So to take down a healthy ash because you think it might die in the future, I strongly suggest not doing that. Plus, a lot of these ashes have dropped seeds, and even the ones that have died, we got a lot of seedlings coming up. And if biocontrol starts to really take off, many of those are going to be the future ashes of our forests. So please take care of them as well. We're not going to give up on ashes. There 93 species depend on ashes. We can't lose them.
Related tree question, can you talk a little bit about oak decline and how we can help? Here in northeastern Illinois, we're seeing a lot of mature red and white oaks dying in our preserves.
Yeah. Those are those diseases we brought in. We got oak wilt, we've got sudden oak death syndrome, we've got bacterial leaf scorch. These are all challenges to oaks. The good news is, again, there is resistance in all of those populations, and actually a fair amount of resistance. It's not 1 or 2%. It's 15, 20, 25% of the oaks have resistance. We're losing a lot of oaks. There's no doubt about it. But it's the resistant ones that will make the acorns that the jays will disperse. And in another generation, we will have a lot more resistance to these diseases. But the fault is ours. We keep moving these diseases around, and it's much faster than the oaks can adapt to them.
Mhm. Okay. Um, are there resources for the financial and other benefits of native planting to help convince my HOA to keep our native garden? I actually think that in Illinois, there was recently a law signed saying that HOAs can't stop native gardening. I think that just
Yeah,
happened.
that's true in Florida. Hadn't heard about Illinois, but great. That's a great step
I'll
forward.
try to share that out to the group if I can pull that afterwards.
But you know, that is exactly why I write the books that I write. Like Nature's Best Hope, it is to convince people, like the people in your HOA, that business as usual is it's killing us. It's not the way we need to go, and to give them the reasoning behind it. So I don't know, give them a free book. It's on tape. They can listen to it when they're driving, but all the arguments are in there.
Yeah. Another person talking about light pollution. How can she convince her neighbor, or she convince her neighbors? I mean, we do have some, door hangers. You can take a door hanger that explains the, human and other native natural impacts to,
Yeah.
light pollution. So locally, you could do that.
A lot of people don't care about caterpillars, but they do care about lightning bugs. So you could use that argument. Put in yellow lights, otherwise you lose your lightning bugs and fireflies. So give that a try. But yeah, the neighbor situation is a tough one. How do you convince your neighbor to stop using Mosquito Joe? Because that floats over and kills your insects.
Yeah.
That's a serious concern.
Yeah. Yep. Um, honeybees being dangerous. Recent news has talked about honeybees being dangerous to our native bee population. Well, I think that's competition, maybe.
Right.
Go ahead,
Right.
though.
Right. Honeybee colonies are huge, but 30,000 individuals in a colony. We subsidize them. So even when there's not much forage out there, we give them sugar and keep them going. So at any one time, the number of honeybees, when you have a lot of colonies around that are released into the environment, far outnumbers the native bees, and they're typically bigger. So yes, it's a serious competition for our native bees. If we had a lot more flowering plants in our environments, there'd be less competition. I remember Bernheinrich did a study back in Maine back in the 80s or maybe even the 70s. And he couldn't demonstrate competition. But you can easily demonstrate it now because the honeybees fall in these flowers, they suck up the nectar, and the nectar's gone until the next day when they make it again. So, yep, they do compete.
Yeah. Well, that we do have that law, by the way. They've put that in the chat. So
Great.
that
Great.
HOA, there is some hope on that.
Good.
I really appreciate your time, and I know we're keeping you when it's late and you're not feeling great. So thank you so much for this. We really appreciate your time and
Oh, thanks. Good. Good luck to everybody. All right.
yeah,
Care.
thank you so much. I'll end this. Thanks.